All right, let's talk CCNA. If you're studying for the exam, you know there's that one topic that seems to trip up just about everyone, but it is absolutely fundamental. We're talking about the difference between layer 2 and layer 3. Today, we are going to make this crystal clear. And look, I'm not just saying that. The material we're looking at literally calls this the light bulb moment for passing the CCNA. And for a very good reason. Once this clicks into place, so much of the rest of networking just makes sense. So, let's get into it. So, if you just want the simplest, quickest answer possible, here you go. Think of layer 2 as being for local conversations. You know, moving data across a single room or within one office building. Layer 3? That's for the big leagues. That's for moving data across the entire world. Okay, so we've got local versus global. Let's actually dig into that, because understanding that distinction, well, that's everything. That's where the real learning begins. So here at layer 2, which you'll also hear called the data link layer, the goal is actually super short-sighted. And that's a good thing. Its only job is to get a chunk of data, we call it a frame, to the very next device it's physically connected to. It uses physical MAC addresses to do this, and the whole operation happens on one local network, with a switch being the main piece of hardware. Now, flip that completely on its head for layer 3, the network layer. Layer 3 is playing the long game. It is all about the final destination. It uses a logical IP address to guide its data, which we call a packet, all the way from you to a server on the other side of the planet, crossing dozens of networks. And the device that makes this magic happen is the router. Okay, so this naturally leads to a question you will definitely see on the exam. If we have these two different systems, why in the world do we need both of them, right? Why not just pick one and stick with it? I mean, seriously, think about it for a second. Every single network device has that unique MAC address burned into it from the factory. It kind of feels logical, doesn't it? Why can't we just use that permanent, unique name to send data everywhere? Well, the answer comes down to one word: hierarchy. A MAC address is flat. It's like a person's name. It's unique, but it tells you nothing about where they are. Imagine if the internet worked that way. Every single router would need a global phone book with billions of entries just to find anything. It would completely collapse. IP addresses, on the other hand, are smart. They're hierarchical, just like a real mailing address. A router in another country doesn't need to know your specific house number. It just needs to know how to get the mail to your zip code. It's way, way more efficient. So we've got one system that's like a name and another that's like a full mailing address. But how do they actually work together to get anything done? Well, this is where my favorite analogy comes in: the simple act of sending a letter. So picture this. You're sitting in your office in, let's say, Building A. You've got to get a letter over to your colleague John, who works in Building B across town. That's it. This simple little scenario is a perfect model for how our network data travels. So, what do? First, you write the letter and you put it in an envelope. On that envelope, you write the final destination: John Smith, Building B. That sealed envelope, that is your layer 3 packet. But you don't just throw it out the window, right? You give it to the local mail truck. Now, the truck driver, they don't care who John Smith is. Their only job is the immediate next step: get this thing from Building A to the mail sorting office at Building B. That truck is your layer 2 frame. Okay, but here's where the analogy gets really powerful. And trust me, this is a massive point for the CCNA. What happens when that letter has to make multiple stops along the way to its final destination? This right here is the golden rule. You have to burn this into your brain. The letter inside the envelope, that's your layer 3 packet, is sealed. The address on it never, ever changes during the entire trip. But the delivery truck, the layer 2 frame, gets swapped out for a brand new one at every single stop along the way. So let's say it again, just to be crystal clear. The IP packet, our letter, with its original source IP address and its final destination IP address, it stays exactly the same for the whole journey, untouched, constant. But that Ethernet frame, our truck, oh, that's a different story. Every single time it hits a router, that router basically rips up the old frame, throws it away, looks at the packet inside, and then builds a brand new frame, a whole new truck, to send it on its way to the next stop. Okay, that was a lot, I know. So let's pull all of these ideas together into the ultimate cheat sheet for your exam prep. This next slide is your new best friend. And here it is, laid out, plain and simple. Just look at the contrast. Layer 2, physical MAC address, frames, switches, talking only to the next hop, and it's always changing. Layer 3, logical IP address, packets, routers, talking to the final destination, and it almost always stays the same. Seriously, screenshot this, memorize it. This is gold. Now, one quick thing, because the exam loves to throw curveballs. You're going to hear the term Layer 3 switch. Don't let it throw you off. Just think of it as a switch that's been beefed up. It can do some basic routing, usually to move traffic between different local networks, what we call VLANs. So at the end of the day, here is the simplest rule of thumb to remember. To figure out what layer something is, just ask yourself, what address is it using to make a decision? If it's looking at an IP address, it is performing a layer 3 function. If it's looking at a MAC address, it's a layer 2 function. It really is that simple. And that's really where you go from here. Once you've got this theory locked in, the next step is to actually trace a packet's journey across a network diagram. You'll see for yourself exactly where that layer 2 frame gets rebuilt at every router, while the layer 3 packet just keeps on trucking, unchanged. And that is when the light bulb really, truly goes on.